To elaborate more on what the standard deviation really tells us, it tells us a lot when we're dealing with a normally distributed or approximately normally distributed variable. And again, this is any variable that follows these three pieces. It's bell-shaped, symmetric, and unimodal. So this picture down here shows us something that follows that criteria. What the empirical rule tells us is it tells us that not only is most of our data within 3 standard deviations, but we actually have approximate values or percentages that fall within 1, 2, and 3 standard deviations. So within the first 1 standard deviation from the mean, 68% of our data falls. 2 standard deviations is 95, and 3 standard deviations, well, that's almost all, are 99.7%. So 68, 95, and 99.7%. So we're going to go ahead and use those rules to answer some questions about some kittens because you guys know me and my love of cats. All right, so we've got weights of adorable fluffy kittens that are normally distributed. So they're telling us that it fits that nice bell curve with a mean of 3.6 and a standard deviation of 0.4. They want us to draw the normal curve representing this distribution using the empirical rule. So I'm going to make a really short squat normal curve just so I can fit it in. So our normal curve is always centered at the mean. In this case, we know what our mean is. We were told that it was 3.6 pounds, right? Now, we need to have those 3 bunny hops that we talked about in 2.4. So we're going to make 1, 2, and 3 sections to either side of our mean. And the way we're going to get to these sections is we're just going to add standard deviations as we move to the right. So I'll be adding that standard deviation and subtracting standard deviations, 0.4, as I move to the left. And that's how I'm going to fill in all of the values of the kitten weights here at the bottom. So the next one standard deviation is 4.0 pounds, then we'll have 4.4 and 4.8 pounds, and going the other way, 3.2, 2.8, and 2.4. So we're just continuing to subtract and continue to add. Now, we have a lot of ways we could do this particular type of question. We could use the 68, 95, 99.7 percentages, and I'll show you what that would look like on this next question. So if we want to do the next question, it says, based on this empirical rule, what percent of the kittens weigh more than 4 pounds? So we're interested in 4 pounds or more, all of this area of the curve. Now, we're talking about being beyond this first standard deviation, right? Anything out here. We could do this using the 68, 95, 99.7 by thinking about, okay, well, we know that the area here, but within 1 standard deviation of the mean, we know that this is 68, right? 68% of our data. And since this curve is symmetric, right, we also know how much, since this is everything, this is 100%, that means that the area out in both these sides has to be, well, the leftover. It has to be 32%. And since it's symmetric, the area in this left tail out here has to be the same as this area in the right tail. So this area here must be 16%. So that is the way that you can do these questions using the 68, 95, 99.7. What I find to be easier is instead of doing everything based on those 3 percentages, is to just memorize all of the interior percentages instead. It's just one more, and since you guys have a note card on the test, this is what I would write down. So 68% is in this section, right? That's what we just said. So if 68% is in that 1 standard deviation and it's symmetric, that means there must be 34% on either side. Okay? Then we're moving out to 95%. So 95% minus that 68%. We just added another, what is that, 27%? So if that's 27%, and again, it must be evenly split between these two. So now we're looking at 13.5% in either one of these pieces. And we can keep doing that same game. All right, again, now we have 99.7%. There was 95. We just added another 4.7%. Half of that is 2.35%. And then we have 0.15 left over, 0.15% for that last thing. So these are our interior percentages. This is just a lot easier to work with when it comes to actually answering questions, because now when we're talking about weighing more than 4 pounds, we can actually just add up each of those little slices instead of having to do some weird math of like, oh, what's the leftover? Let's divide it by 2. This is the same thing as 13.5 plus 2.35 plus that 0.15. That'll give us back out our 16% for the answer. So we can go ahead and use those interior percents to do this last question between 2.4 and 4.4. 2.4, 4.4, we want to be between them. So that's anything in this area of the curve. So we're going to add the 2.35 plus 13.5 plus 34 plus 34 plus 13.25. Oh, not 25.5. Another thing you can do is if you know both sets of numbers, those middle percentages and these little interior percentages, you can make this a lot quicker because you can say, okay, this is within 2 standard deviations, and then we need to add this little piece. So you can recognize that this is just 95%. So when you add all this up, you're going to get 97.35% as our percent under the curve, or the percent of adorable fluffy kittens that weigh between 2.4 and 4.4 pounds. So that is the empirical rule. I'll get us some more examples to work through so that you guys have one to try on your own.